Hey there, everybody. All right, so we need to, oh boy, hold on. Where is it? There we go. All right, so we finished in the last video talking about parts 1 and 2, and now we're going to look at part 3. Oh, before we get to this though, and this is in the post on Classroom that this video was in. I gave today the name or the numbers of all the different elements that you need to know the names of. The numbers are all there, like 1 through 20, 22, 24 through 30. So all of those, I typed all that in. I gave periodic tables, the kind of periodic tables that we will use in here that's going to be kind of part of your textbook. I put a copy of that, a PDF file of that attached to this post as well. And then if you weren't here, when you get back, I'll give you a hard copy because the paper is actually an 8.5 by 14, so it's a larger size paper. So you probably wouldn't have something that size to print at home anyway. So I will get you a hard copy of that when you get here. You'll have to remind me because I probably won't remember. But I gave those out today, and I went through the numbers and then pronounced all the names of those elements. So we'll be doing that in class as well. And I'll probably include that in one of the videos coming up. But you will need to know the names of the numbers of the elements that I gave you. You'll need to know those by December 1st and 2nd. They're like B1, B2. It's the 1st and the 2nd. So when you come back after Thanksgiving, that's when you'll have to know those names. So you've got a while, but don't wait until like the Monday after, because that Monday after Thanksgiving, we have a work day, November 30th. So December 1st is Tuesday. That's your first day back after Thanksgiving. So do not wait until Monday night to be scrambling and learn the names. Okay, anyway, back to this. So this is part 3. You should be able to answer these questions without actually looking at the Build an Atom simulator. Okay, after you've seen everything that you've seen, you should be able to answer these questions without having to look at that. So I am going to hopefully use the little text boxes here to answer these questions. So when you add a proton, does the element name change? Yes. Hold on. And then over here you say, if so, how? How does it? The name changes to the next element. Oh gosh. How about it changes to the next element? Oh boy. Okay, it fit. And does the position on the periodic table change? Yes. If yes, how does it change? It shifts to the right and or down a row. Hold on, maybe I can do it this way. There we go. Shift to the right and or down a row. Now I don't know if you noticed that, but when you're in here in the Build an Atom simulator, let me get back to that right here. So if I take one of the protons out, you'll see it's up at. Oh, am I in the way? I can't move up any further. So you can see helium is highlighted here, and so when I put another one in, well, hold on, let me just start with hydrogen because I can. Oh, drag that out. All right, so with hydrogen, I'm over here. I add one, it shifts to the right. I add another one, it shifts down to the next row. And then as I continue to add them, it shifts to the right. And once you would get to neon, if we could go any higher in this, then it would shift down to the next row and then go across from left to right. So that's how it's changing its location in the table. And where was I? Right here. So, does it change the charge? When you add a proton, does the charge change? Yes. And if so, how? Well, if you add a proton, the atom becomes what? More positive or less negative. It could be both, right? So if it was negative and you threw another proton in there, then it's going to become less negative, or it could become more positive by adding positive charge. Now, here's something else I want you to make sure that you are getting here is that the proton number does not change. You don't alter the proton number. So I know it says if you add a proton, but see, when you add a proton, it becomes a whole other element. You can't do that. Like the proton, it's locked in. The proton and neutrons in the nucleus, they can't come and go. So we aren't adding protons to the nucleus to make them charged. Like if you want this lithium atom to become a positive charge, what do you have to do? For this stable, neutral lithium atom, what has to happen for it to become positively charged? Again, I hope you know you can't do this. That does not make, now, is it positive charge? Yes. But is it still lithium? No. It's not even the same atom anymore. So you can't just start throwing protons in to make something be positive. So how do we make lithium positive? Well, you have to take out an electron. You have to remove one of the negatives. You can't just add the positive in there. You have to remove a negative to make it positively charged. So I hope that makes sense. All right, back to this. Does adding a proton affect the mass? Yes. What does it do? Gains 1. So mass goes up by 1 when you add a proton. Yes. I mean, yes. That's 4. All right. Removing a neutron. If you remove a neutron, does the name of the element change? No. How about if you remove a neutron, does the position on the periodic table change? No. If you remove a neutron, does the charge change? No. And again, I hope that you've seen this. I hope you can answer these without having to go back and check because you've done all of this. The neutron doesn't have a charge. Now, when you remove a neutron, does the mass change? Yes. What happens to the mass? Goes down by, and I should say this, goes, instead of gains, I should say goes up 1. How about that? That's probably better. So, as you can see here, the neutron, it doesn't affect the element identity, position on the table, or the charge. It only affects the mass. Now, if you remove an electron, does the name of the element change? No. Does its position on the table change? No. Does the charge change? Yes. How so? Well, if you take away an electron, what do we see? If you take away an electron, it becomes positive, right? Or what if you already had more electrons than protons? So now it's -2. If I take one away, it becomes -1. So it becomes less negative, or it becomes positive. So it could become less negative or more positive. The same thing we just said up above. So it becomes less, which is a minus sign, less or more. Oops. Okay. And does the mass change when you remove an electron? No. Again, you hopefully saw that in the previous section. All right, so now it's add an electron. So now it's add, if you add an electron, still no. Position change, still no. Does the charge change? Yes. How does the charge change? So now you're going to add an electron, so it could become more negative or less positive. That makes sense. Because if it's already positive and you start adding negative to it, it's going to become less positive. And if you get past neutral, then it's going to start becoming more negative the more negatives you put in. And again, is the mass affected by the electron? No. Now, remember, all these answers and questions here. The proton, what does it do? It does everything. It is the identity. It determines the position on the table. It changes the charge or affects the charge, and it affects the mass. All of them. The proton does everything. The neutron only affects what? The mass, because it has no charge. The electron only affects the charge because its mass is so teeny tiny. The mass is teeny tiny. All right? It's not that it has no mass, it's just very, very, very small. I hope you're getting that. Then you were supposed to go to the symbol tool and figure out what the symbol tool tells us about the parts of an atom. Well, where is that? And you may not have even seen it or known that there was something on here. But down here, oh gosh, I wonder if I can get it with this thing in the way. There's a little symbol box down here. If you click on that, maybe, then it brings you, oh, look at this. We have now a little symbol tool, a box that has some information in it. Now notice, we have this number up in the corner here, which is our charge number. Then we have this number up here, which if you notice this scale here, this must be telling us the mass, okay? And then down here in the bottom left where you see a red number, those are the protons. 1, 2, 3, we have 3. So that is the proton number here. We have the mass number up here, and then we have the charge on the upper right. Now, the thing about this, different periodic tables have these bits of information placed in different locations, right? Although none of them have a plus or minus or a 0 in the corner for charge. That is unique to the Build an Atom simulator. That is not normal on a periodic table, okay? But the proton number is, and the mass number is. Typically, like on the one that I have hanging on the wall in the room, that one, the proton number is up in the upper right corner where the charge is. The mass is down below, which is normal. The periodic table I'm giving you that I actually posted on Classroom as well, that one has the proton number top center, and the mass is down below the symbol. Usually the symbol is somewhere in the middle of the box. So that's the symbol tool. Okay, it shows you the mass, shows you the proton number, and shows you the charge. Then for this assignment, you were supposed to create a couple of symbols for 2 different elements. So hopefully you did that. And again, it doesn't really matter which ones you picked, but hopefully you get the fact that the one number is the proton number, the other number is the mass number in the upper left, and then in the upper right, you have the charge, plus or minus, or 0 if it's neutral. Then what we did in class is I gave a couple of examples of kind of like, oh, let's see here, hold on. If I click on this, oh, geez. If I click on this, a couple of these. So like when you were sketching these elements here, these atoms, I gave a couple of examples of that and then had everybody practice them. So if I tell you, so I'll do one for you here. Let's go back to this. If I were to say, oh no, oh this dang thing, hold on, I'm having a problem. Okay, there we go. Oh, I hope I can write on this thing. Oh, geez, it's probably. Oh, I hope this works. Well, this may not work. Right. Of course it did that. Extend the page again. I gotta drag this thing down. Gotta write this down here. Okay. It's this thing is in the way here. Okay. Oh my gosh, what is happening right now? This thing is not cooperating. Okay, finally it's working. Okay, let me get this extended. All right, here's what I might ask you to do. I would say something like sketch and, oh my gosh, I can't write. An atom with a charge of -2 and a mass of 13. So I might ask you to sketch, again, an atom that has a charge. Oh, geez, now I'm in the way. I tell you, oh my gosh, this is just not my day. Okay, so sketch an atom with a charge of -2 and a mass of 13. And what you would need to do is make sure that you have a key I would have a key off to the side that shows, okay, I'm going to make my proton red. Or I guess, you know what, instead of doing a solid color, because most of you probably won't have colors to use, let me get that out of there. You could just do this. So do like a proton like this, a neutron that's hollow, and then an electron that's solid. That might be the easiest way to do that. And then I will say, that's my proton, that's my neutron, and this is my electron. So up to this point, you've been using the Build an Atom simulator to do this. But at this point, you need to try to do this on your own without the simulator. And you need to be able to name. You need to be able to name which element it is that you are building. Which means the periodic table that I gave you, that's going to be pretty important because that has all the names on it. So you'll have to reference that probably as you do this. So if I were you, I would try to pause the video now and then do this using that periodic table that I posted, that's in this post. Use the periodic table, make an atom that has a charge of -2 and has a mass of 13. There's multiple answers that you could have for this. So do that now and then come back and then I'll show you one that I might make. So I'm going to go ahead and do that now, but you pause it, work on this, and then come back. Okay, so I'm going to have, let's see, oh, it's not even red, I tell you. Oh boy, you can hardly even tell. I made this thing too small. I gotta make this bigger. There, I think my rings were too small. Okay, 1, 2, 3, 4, 5. So I could just stop with 5, and then I would need, let's see, 1, 2, 3, 4, 5, 6, 7, 8. Now, why did I do that? Well, the fact that I had 5 of my protons here, that tells me that this already, what element am I dealing with? If I have 5 protons, 1, 2, 3, 4, 5. 5 protons means that this thing has to be what? Hopefully you looked it up on the table and you saw that it has to be boron. Okay, has to be. Now, how did I know to put 8 neutrons in there? 1, 2, 3, 4, 5, 6, 7, 8. How did I know that? Because my mass has to be 13. And you're supposed to remember that proton plus neutron number is the mass. So my 5 protons and my 8 neutrons total are my 13. Okay? Now I have to figure out, okay, well, how many electrons do I need? Well, I want a -2 charge. So with a -2 charge, what is the charge on the protons? Remember, they are pluses, the electrons are minuses. So I have 5 pluses. So right now, currently, I have 5 protons, 1, 2, 3, 4, 5, and those are all positively charged. So I have 5 pluses, but I want the atom to have a charge of -2. So how many electrons would I need to make the charge -2 if I already have 5 pluses? That means, again, I need 2 more negatives than positives. It's not telling me I need 2 electrons. It's telling me I need 2 more electrons than protons. So I'm going to need 7, right? So I'm going to need 7 electrons. So 1, 2, 3, 4, 5, 6, and 7. Whoa, that's kind of messy. So this atom satisfies the requirements of having a mass of 13 because I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so I have 13 in my nucleus, which means I have a mass of 13. I have 1, 2, 3, 4, 5, 6, 7 electrons. So 7 minuses and 5 pluses makes a net charge, we would call it, like they did in the simulator, a -2. And it's boron. So this is the kind of thing you'll have to do for the quiz that's coming up that we'll have on the next class period that we have. Short little quiz, but one of the things you'll have to do is this. So make sure that you can do this. If you need some more practice to do this, then let me know and I can provide you with some more practice. But this is what you have to be able to do. Knowing that the protons plus the neutrons is the mass, and the difference between the protons and the electrons is the charge. Hopefully that makes sense. Let's see. There's one other thing. Then I posted, and this is already on Classroom in the previous post. Oh gosh, where is it? Where's Classroom? Right here. I have this right here is wrong place, stream. This is called a mass ranking task. So the mass ranking task, I can make this bigger. Let's see if I make this bigger. Whoa, what the? So this, I was having people work on in class as well. You need to look at these images here and figure out what the lowest mass is up to the highest mass. Now, how do you do that? Like, how do you figure out what the masses of these things is? Well, I hope you know by looking at the actual models of the atoms here that you just have to do what? I hope you're thinking that the protons and neutrons are what's in here, and then when you count those up, that is your mass number, right? When you count those up. So this you can count, this you can count, you can find those pretty easily. How about a plain old B by itself? Well, then you have to look at the periodic table and look it up because the mass is on the table. It points to the number that is mass and it tells you what it is. So you'll have to look that up. Same thing with F down here. Scandium is what that is. It's number 21 if you can't find it. So you'll have to look that up on the table and then write it down. And then these two, they give you the little symbol tool things that we had from the simulator. And so if you're looking at these and you're not sure what those are, well, remember, oxygen is number 8. So if you look at the periodic table and you see the oxygen is number 8, then what the heck do you think this 16 is up here? That 16 has to be the what? It's not the proton number, because proton number is 8. Oxygen's proton number is 8. And so 16, I mean, the -2 is what's telling us what the charge is. But this is the mass, okay? That is the mass. They gave us the mass in the box here. And again, it can be confusing because of the location and how you're supposed to know that it's in the upper left corner. But if you know that oxygen is number 8 on the periodic table, that has 8 protons, that's the identifying number, then the only other logical conclusion is that the 16 has to be the mass. Now for the carbon down here, it is number 6 on the table, and that means it has 6 protons, which means that the 14 here, it has to be the mass. That has to be the mass. So hopefully you looked up in the table and you found out that the boron here is 10.81 on your table. Oh, and I can't write on this either. Oh, no, well, maybe I can. Oh gosh, 10. This is going to be terrible. 0.81. This is bad. That's 10.81. Now how about here? We got 1, 2, 3. They're like little olives. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. All right, so here we're 17. Here we are at 16. Oh, I just covered it. Oh no. Oh no. Okay, let's try this again. There we go. That's better. And then here we have to count them again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if maybe you should pause the video. Maybe you should have already I probably should have already told you to pause it. And then just try this. Try to figure it out. And then tune back in and see if you get it right. What did I say here? I think I said 12. And then here, well, they give it to you right there. And then scandium, you're supposed to look that up. And I think it's, if I remember correctly, it's like 44.9. Oh boy. Depends on what table you look at. If you look at the one I gave you, I think it's 9, 5. Oh gosh, 5, 9 or something like that. So clearly now, A is the lowest. Then what? Let's see, D. Okay. And then let's see, E. And then C. B. And finally, F. Is that right? Hopefully that's right. A, D, E, C, B, F. Yeah. So that's a mass ranking task. It's using what you know about atomic mass to put things in order. So again, next class we have, there's going to be a little short quiz, 5 questions, one of which you'll have to sketch an atom model. There'll be some questions about mass and what each of the particles does in the atom. And yeah, how things can become ions or charged atoms, those kinds of questions. So hopefully you will remember all that you've worked on for the Build an Atom Simulator in the last 2 little worksheets, and you'll do fine. If you have any questions, though, you can let me know. So I will talk to you soon, hopefully. Take care of yourself.